Alright guys, so hello and welcome to this video tutorial for RC Hibbeler's Engineering Mechanics Statics textbook. So we have this problem from chapter 5 here, which is saying the uniform rod AB has a mass of 40 kilos. Determine the force in the cable when the rod is in the position shown. There is a smooth collar at A. Okay, so I've kind of replicated our diagram on the right hand side here just so that I can make all kinds of scribblings all over it. Now, one thing I'll say before we get into this problem is I'd first of all recommend kind of neglecting forces acting at C. Just isolate the rod, just concern yourself with the rod. Let's add some forces to our diagram here. So we've got a 40 kilo rod here, so it would be safe to assume if it's of uniform density across the rod, that 40 kilos can be described as a 40G weight acting in the middle of the rod. We've also got a horizontal reaction at A. Let's just call that AX. We have a vertical reaction at B. Let's just call that BY. And we have what we're looking for, the tension in the rope. I'm going to label it in blue here, TBC. Now, we're dealing with three unknowns here, right? The reaction at A, the reaction at B, and the tension in the rope BC. Now, there's two things that we can almost say off the bat by inspection, right? We can do a vertical equilibrium. We can say the sum of the forces in the Y is 0. Therefore, things acting up are equal to things acting down. We've got By acting up and 40G acting down. Therefore, By equals 40G, which I happen to know we can express numerically as 392.4 newtons. So that is a handy figure off the bat. And we can also resolve horizontally. So the sum of the forces in the x is equal to 0. Things acting to the left are equal to things acting to the right. Therefore, well, what have we got acting to the left? We've got TBC, which is what we're looking for, right? And acting to the right, we've got AX. So we note that TBC and AX are equal to each other. We've got two important ideas here. We've solved for BY and we haven't solved for TBC or AX, but we know that they're equal to each other. From here, I'd recommend introducing a moment idea. So we can take moments. Personally, I'd suggest taking moments about point B here, but I don't think it really matters. Let's take moments about point B. We can say the sum of the moments is equal to 0, or in other words, the sum of the moments acting clockwise is equal to the sum of the moments acting anti-clockwise. So what have we got acting? Let's start with clockwise. Well, we've got a clockwise moment from AX, and that's kind of it. So if we're noting that a moment is the product of the perpendicular distance from the point about which you're taking moments and the magnitude of the force producing that moment, then we almost need to determine this kind of length here, right? I'm diagrammatizing it really poorly, but we need to determine that length there. We can make use of this kind of 3-meter length idea that I've shown next to the diagram, and note that we're kind of looking for this vertical length here. Noting that this angle here is 60 degrees, then this angle here must be 30, right? And we can say this is a right angle and this is 60 degrees here. We could express this vertical length here as 3 cos 30. You could express it alternatively as 3 sine 60. They're the same numeric value, right? I'm going to express it as 3 cos 30, and this length here we can describe as 3 sine 30. So the moment produced by AX then we could describe as AX times 3 cos 30. Let's move on to the anti-clockwise moments then. So we have an anti-clockwise moment about B produced by this 40G force here. We note that it's kind of half this perpendicular length here. So I'm going to describe that as 1.5 sine 30 times 40G. So that's our moment there. And we know we can rearrange this equation for AX here. We can say, therefore, AX is equal to, well, when we divide by 3, we'll note that we'll get a half emerging from that. And when we divide by cos 30, in case you weren't aware already, it's a helpful thing to know sometimes, the tan, not just of 30, but of any angle, is equivalent to sine of any angle over the cos of any angle. So when we divide by cos 30 here, we could simplify that down to tan 30. And the 40g hasn't gone anywhere, so we could just put the 40g in our numerator here. And hopefully when you put that into your calculator, you should obtain a value of 113.3 newtons. So that's our value for AX technically, but we note that AX is equal to TBC, so we could just make that extra clear here, and that is the solution to our problem. If you have any questions or comments about that problem, please feel free to leave them down in the comment section down below. Otherwise, thank you very much for watching.